Hey class, welcome back. Today we're going to be going into Module 4 and talking about App ID. App ID is essentially a way that Palo Alto uses to control which applications can talk to what applications can come in, what can go out. It's not as simple as it sounds. It's actually very technically detailed, and a lot goes behind it. So specifically for this video, we're going to be talking about how App ID reduces attack surface, concepts and operations, configurations, unknown and encrypted application traffic, migrating App ID based on security policy, and updating App ID. Now, let's scroll down. So what is an application? An application is just a specific program or a feature whose communication can be labeled, monitored, or controlled. The term application does not have an industry accepted definition in the way that session or packet does. In Palo Alto, an application is a specific program or feature that can be monitored, can be labeled, and controlled. Now, applications can be delivered through a web browser, a client-server model, or a decentralized peer-to-peer design. Peer-to-peer meaning one host directly talking to another host. Okay? Now, App ID, what is it? App ID essentially enables you to see the applications on your network, and you can learn how they work, talk to one another, the behavior characteristics, the type of data, the ports, the session, the metadata of how they all interact. Okay? And based off of that metadata, the analytics, you can filter, you can allow, deny, group different applications together based off of all that metadata. Okay? And that allows you to very granularly understand and allow what's coming in and what's going out, what people can use and what people cannot use. Now, the way App ID works is that there's a methodology, right? Applications create traffic. As traffic comes in to the firewall, you have your some type of workflow or engine to say that the App ID will check through, right? There's a series of questions. It will go through that workflow. It'll go through like a decision tree. And based off of the decision, it will move on to the next decision. Now, when traffic comes in, the first thing that App ID checks is if there is some type of signature associated with that traffic. Usually applications have known signatures associated with it. These signatures, like in old firewalls, you can immediately block allow based off of the signature. But because that's like very rudimentary, that's the first thing it checks. Like, oh, is there a signature? And based off of your security policies, which signatures are we allowing? Which signatures are we denying? Okay, so if there's if the traffic does have some type of application signature associated with it, the firewall will check the signature and hit it against the security policies that are already pre-configured. Okay, if it allows it, awesome. If that signature is blocked, then it'll block it. Now, something to note is that sometimes things come in encrypted. So one thing that the firewall will do is if the firewall is configured and you have procured the decryption functionality, SSL decrypt on the firewall, it's really expensive. Not many people have it because of the price and their resource is that it exhausts to decrypt traffic, and it creates a lot of overhead. So it's good from a security standpoint, but from a usability standpoint, SSL decrypt, it does kind of get lost in usability. But if you do have that function, it will also check before hitting it against the security policies. It will take that traffic, it will do some SSL decrypt before it hits the application signatures against the security policies. All right. Now, next. So pretend there is no, it does the first check, right? Is there an application signature? Now, if there is no application signature associated with that traffic that's coming in, it will identify known protocols, okay? So if it can decode and understand, and if there is a protocol associated to it, it'll say, okay, these protocols, I was able to successfully identify them. Let me hit them against our security policies or our firewall rules. Remember, security decryption policy, those are called firewall rules in a sense, all right? So it'll send those that traffic against the firewall policies and say, hey, is this protocol allowed or are we blocking it? When I'm talking about protocols, I'm talking about SSL, SSH, Telnet, all right? DHCP, DNS, whatever it is. Now, hypothetically, so AppID could identify an application in decrypted traffic and apply the application security policy based off of that specific protocol. Now, the firewall might also identify a protocol and then use its heuristics to pinpoint behavioral patterns consistent with the application. So BitTorrent is an example of an application where the firewall must use heuristics to identify the application traffic. So in addition to that, it will also look at how that traffic is moving back and forth and some additional metadata. If it can identify some behavioral heuristics that is well known, then it can also take that traffic and then hit it against your security policies to either allow or deny. So BitTorrent interacts in a very specific way based off of the communication that goes back and forth. The firewall is smart enough to pick up the way it interacts, the behavior, and take action upon it. Now, if there's no known signatures, there's no known protocols, there's no known behavioral heuristics, then the traffic is marked as unknown traffic. And the unknown traffic will then be sent against your security policies. And you can have dedicated security policies that says, we will block all unknown traffic or whatever it is. So it'll just be labeled as unknown traffic. And you can either allow or deny or be as specific as you want of how to handle that unknown traffic. So now, in addition to that, let's go back to this protocol decoder, right? Identifying protocols. So if a protocol is identified that, let's just say HTTPS, all right, yes, that's identified. We're going to allow HTTPS to come in. The thing is that the firewall continuously checks on a consistent basis against that traffic that's coming in, because one thing that apps can do is that it can not necessarily mutate, but it can shift into a new protocol. So what the firewall does is it continually checks the traffic to see if a new protocol is starting to be used, and then it can run additional security policies against a new those new protocols that are being used, either allow or block it. Sometimes there's a lot of malicious activity that will come in as a specific protocol and then shift later to a different protocol to do malicious things. Okay. Now going from port-based versus next-gen firewalls. So traditional firewalls you allow a specific port to be open, and what would happen is that you can do whatever goes across that specific port, that type of traffic will be allowed or denied however if you want to allow, in this example, port 53, all right, DNS. If you turn traditional firewalls, if you leave allow 53, then anything that's using port 53 will be will come in. And so what threat actors would do is that they would utilize port 53 and obfuscate their malicious activity to go through that specific port because you have an opening. Your opening is port 53. So even though that, typically they go through port 80, all right, let me reconfigure my protocol and allow and make my traffic specifically go through port 53 because I know there is an opening, there's a loophole, there's an opening, and I can go do my malicious things. Now, in Palo Alto firewalls, any next-gen firewalls, it doesn't have to be Palo Alto, what they do now is because they know that there's different services that can leverage the same port. Like even though port 53 is pretty much dedicated to DNS, there's ways to like reconfigure your traffic to still go through port 53. So what next gen firewalls can do is based off of the service. You can unblock based off of the service and still like open up port 53, but only allow DNS services to go out of port 53. So you can go more granular and only allow specific services to work off of port 53. So here it says a protection is not available on a network. On a port-based firewall, DNS would be allowed on port 53, but so would other invasive applications attempting to use port 53, such as BitTorrent. But here, but here the firewall allows only DNS on port 53 and denies all other non-DNS traffic on this port. So for the next gen firewall, so it will block BitTorrent and deny it. Okay. Now, if we're talking about 0 days, right? The previous example described a well-behaved known threat. All right. We know BitTorrent is bad. We'll block it in advance and be granular in that sense. But hypothetically, if there's a 0 day, we don't know what kind of service that is, right? So if we say we want to open up DNS and then block specifically BitTorrent, what if there is something else that's bad, right? So it's very specific on how you want to block based off of ports. You don't want to just say allow and then only block BitTorrent, because what about all the other 0 days or the other things that may use 53 to attempt to attack you? Okay. So what next-gen firewalls you can also do is you can say allow anything on port 53 that's DNS service, and then block all other services associated with port 53. That way, if it's a 0 day, if it's BitTorrent, if it's anything else other than the DNS service itself, it'll block it, but we'll still allow DNS to come through. Now, App ID can also work on that TCP communication. So applications that use TCP usually require multiple packet transfers to identify an application. So when there's TCP, there's that three-way handshake, the SYN, SYNAC, ACK, and then you get the GET. So throughout the three-way handshake, right, there isn't really any application data for the firewall to be able to determine what kind of application it is. It doesn't have really metadata to be able to filter, block, allow, whatever it is. So the firewall actually has to sit back a little bit and wait until it gets a GET request, or like the fifth packet in a sense, to be able to get that information, that's the application information itself, that metadata, to either block or allow. Okay? And if the traffic is encrypted, the firewall must evaluate the administrator-defined decryption policy to determine what to do next. So when there's encrypted traffic, it really does throw a wrench in the way that the firewall reviews the policies and what to do next. Usually that's why you want to, from a secure standpoint, you want to have that SSL decryption in the front end so you can read that data. Otherwise, everything's encrypted. You don't know what's happening, right? And you're just passing through encrypted data. That's very risky. So that's why you have to set up like encryption and decryption policies of what you want to do with encrypted data. But that's for a later module. Classifying and labeling TCP traffic. Applications that use TCP usually require multiple packet transfers. Okay. So there's several different ways to label TCP traffic. Not applicable, incomplete, insufficient data, unknown TCP, and unknown P2P. So not applicable is when the firewall discards that traffic because the security policy does not allow it, straight up. For example, suppose a security policy allows HTTP traffic only on TCP port 80, but the traffic arrives on a different port, like port 66, right? Because it's not on port 80, it'll block and it says not applicable and it'll drop the traffic. Now, incomplete, the label of incomplete, the three-way handshake did not complete or was followed by no data. So in that case, the traffic is labeled as incomplete by app ID, and it's not an application, okay? The next label is insufficient data when not enough data is received in the payload to identify the application. In this case, the three-way handshake completes, but more information needs to follow in the handshake to identify the type of traffic. Next, you have unknown TCP when the three-way handshake completes the data flows, but app ID cannot, it has enough information, but it just cannot identify the application. And then same thing with unknown P2P, but more specifically for peer-to-peer behavior. Okay. Now that's for TCP. You know, that's all done through the TCP handshake, as you can see here, the SYN, syntax, and data going back and forth. Now for UDP, it's a little different. A Palo Alto firewall examining UDP packets often must examine only a single UDP because remember, UDP, there's not that three-way handshake or that double check to make sure for reliability that it was received. The UDPs are just straight through, right? The packet includes all source and destination addressing information. It also consists of application data used to identify the traffic, so it can process it. The UDPs are immediately processed. Okay? But it will still go through labeling, but there's less labels. There's not applicable, whether, all right, I received this UDP packet, it's not applicable because you are trying to get to port 180 over port 123, I'm blocking you, all right? And then there's the unknown UDP, it's just unidentifiable UDP traffic, same with P2P. All right. Going next into app ID concepts and operations. Now, network traffic can shift from one application to another during the lifetime of a session. This is what I was saying earlier. When, for example, you're using web browsing, and then the web browsing, you're using a different type of application or a functionality or service within web browsing, so the protocols change and shift to like the app-based that's on the web browser may be using a different protocol to do its functionalities. So it will shift in a sense, and you have to have different firewall rules to be able to allow that new shift, that new protocol to still be able to connect and do its thing. Otherwise, it's going to be blocked. Okay. So another instance is App ID can report the application as web browsing. Here's just an example. When an HTTP GET is detected, but as more packets are received, App ID might further classify the traffic into something else, because it first comes in as web browsing, the first few packets, and then, I have more information. I can say, all right, this is actually moving towards the specific application. It's going towards a generic app chat protocol. Okay. Now, some applications are dependent on one or more other applications. Network traffic can shift from one application to another during its lifetime. That's why when you create a policy for applications, you have to ensure that it also allows all the dependencies, whether it's the parents and the child or the child's. Now, by default, usually there's an implicit allow of the parent dependency, but you have to be more specific about the children. Okay? So just going through an example here, let me see if I can actually scroll in a little bit. That might be a little better. We have Joe right here in the user net zone, and he wants to access Office on Demand. Office on Demand. All right. In the internet zone. App ID scans the traffic and finds an HTTP GET request, which matches the SSL application. The first rule is matched and the HTTPS connection is allowed. So look at this one, required apps, SSL web browsing, will allow it to go through. The Office 0365 rule is not checked because a matching rule has already been found. Remember that we go top down when we were looking at ACLs and the policy rules. One was already good to go. We matched it, we're out. If we didn't match rule 1, then we would drop to rule 2. Now, because security policies rules are examined for every packet, the firewall can detect application shifts within an established session. When Joe tries to access Office on Demand, an application shift in the current session is initiated. The App ID engine detects the shift and finds the application signature for Office on Demand, right? Because we're first going via using web browser, we're web browsing using SSL, so we're allowed. Now that we see a shift of the web browsing to Office on Demand application, then there's going to be another trigger to go check against that application to see if it's allowed. Okay? The Office on Demand application does not match the first rule. All right, so because Office Demand is not this first rule, but when we go to the next rule, right, down one, it goes to the next rule down, allow Office 365, yes, the application is there and we allow it. Usually the order matters, but in this instance, it doesn't. It says in this example, the order is not relevant. Traffic that matches one rule cannot match the other. True statement. All right. But here's the thing. When you explicitly allow Microsoft Office 365, the parents usually implicitly allowed. But you never want to explicitly allow the parent, because other children's services under it could be allowed and they can be used for unauthorized things. People can use it, abuse it, and we'll go into that in a little bit right here after this one. So Palo Alto maintains a database of known application signatures by the App ID engine. Each signature covers multiple versions of the application. You can access this by doing a quick search. So by going to the objects and then applications. Now in this example, notice the two applications listed depends on fields. On field must be allowed explicitly on the firewall to use the application 0365, right? You'll see here 0365, this object, it dependent on SSL and web browsing. So this O365 will not be able to be leveraged or even used. It will be blocked if these two are not allowed. Okay. And before, when you want to make configurations and firewall rule changes, Panda's pretty smart. Next-gen firewalls are pretty smart in general. Before you commit and make a firewall rule change to allow a specific application to come in or out, before you commit and save, the firewall will, if the application is in its database of known signatures, it will list out all the different requirements and the dependencies before you commit that you need to make sure that is allowed. So in this instance, you're trying to commit a save and say allow any O365 base application to come through. Here it says before you save this commit status, it says it requires SSL and web browsing to be allowed. Right? It'll actually give you a warning. Hey, before you save this, make sure these are allowed, or these are not allowed. These are not allowed currently. Go update and make sure that these are allowed. Now, what I was saying before is many common applications implicitly allow the parent application, so no need to explicitly define these applications in a security policy rule. They are automatically allowed. So in this instance, Facebook base implicitly allows web browsing and SSL, so no need to add them for the rule. For many applications, that AppID database implicitly allows the required parent application without the need for you to add the parent application in the security policy. In this example, the Facebook-based application implicitly allows. So we have this firewall rule, this Facebook application. We have the application, the Facebook base, the Facebook chat. Obviously, to even access Facebook, you need to be able to get on the web. You need to do web browsing. You need to allow SSL. Okay? So those are kind of given, the rhetoric. You have to have those to even get to here. So they're implicitly allowed. Now, AppID defines implicit dependencies because adding parent applications to a rule in the security policy could allow more traffic than intended. For example, the enablement of web browsing to allow Facebook base would enable users to browse other websites. An administrator must configure additional security policy rules to control other websites. Security policy administration is simplified when AppID implicitly allows the parent applications. So you don't want to necessarily say allow web browsing. You allow the application has a parent or dependency of web browsing, so it'll automatically be allowed. You don't want to explicitly write out allow web browsing because there's, let's say, BitTorrent, right? If you allow web browsing in general, what if someone wants to use BitTorrent application? They'll be able to go through, right? So you want to use that implicit rule. Now, there are ways to override that, but that goes beyond what we're talking about today. Now, application groups and application filters. So application groups, a way to manage applications. There's so many applications out there, right? Now, a way you want to manage them more, administer them, and manage them a little more intuitively. You can group apps together that are relatively similar. It helps from an administrative standpoint, quality of service standpoint. So, for example, if you want to allow only specific social media, you can websites or applications, you can group the specific social media group applications that you want to allow your users to get access to. In this example, Twitter, Facebook, and YouTube, right? Let's just group them together and we can apply security policies off of that application group rather than putting security policies on each individual, creating 3 different security policies, one for Twitter, one for Facebook, one for YouTube. We rather group the social networking applications together because we already know that their security policy is going to be the same. So let's just have one security policy against the application group. Allows us to be a little more dynamic, add, remove as needed. Now, another thing is application filters. What application filters do is that every application has different type of metadata. That includes the category, subcategory, risk, tags, different characteristics. So what you can do is you can create filters. Filters are specific objects. So you can filter based off of specific application metadata. So let's just say there's a tag, right? The tags or risk, right? Let's say the specific characteristic of a risk. You can filter based off of all level 1 risks for all applications out there. And then you can put a security policy against a specific filter. So you say, I want to block all level 1 risk applications, right? It's a filter. So there's a difference between filter and groups. Groups are you're actually like putting the applications together into a group. The filters themselves, each application has its own characteristics and its metadata, and you're creating an object saying based off of one specific metadata, the risk or the subcategory, I want to put a policy against this specific subcategory or this specific tag. Okay? So here it's like a nested group of filters and groups. So you can have an application group and then create a security policy against that application group for only specific application filters for all the applications within that security group or that application group. Okay, so here you can see you can do application filters against groups and security policies. Okay. Now, predefined and custom application tags. So Palo Alto assigns one or more tags to the application in an ID, app ID. Tags are updated as part of the normal application and threads content updates. So whenever you're updating, tags do get your firewall dynamic updates. You will get updated tags as well as needed. And then you can do some filtering based off of those tags. App ID allows you to reduce the attack surface because you're specifically allowing what to come in and denying everything by default. That's like the best way to approach things. They say this is called like a positive approach. It's really deny by default and only whitelist things that are needed. Okay. Now, when you block something, you can actually set something up in the firewall to have like a generic page to pop up saying, oh, this application is blocked, right? I don't think we do that in our labs, but it is something that you can do. Say, oh, you're trying to reach this specific application, it's going to be blocked, and it's going to show a generic blocked site. Now, you can view applications using in the traffic log. So we will be going through how to view traffic in our logs, and you can definitely filter based off of the application itself. And yeah, that's kind of like just generic information right there. Now, unknown and encrypted application traffic. So there's two different types of traffic that come in, right? There's encrypted and decrypted. Okay. Or let me correct myself. There's identifiable traffic and unidentifiable traffic. Okay. So applications known to App ID, it will immediately be able to track, tag, label it, and hit against security policies. Okay. Now, those unidentifiable apps are a little more discrete, and requires a little more thought behind how you're going to process them. Now, if it is unidentifiable, initially what it will try to look at is this encrypted or not? Okay? If it is encrypted, then you may have different policies in place where you can do some SSL decryption, or allow it to go through directly, or just drop it. But if there's no encryption added on it, and you can read it in a sense, but it's still unidentifiable, App ID might be able to still identify it through different mechanisms. It might be initially identified as generic web browsing, but as more packets come in, App ID can then further identify that generic web browsing application. For example, web browsing might be further identified as Google Docs based. So, right, web browsing, we don't know exactly what application is coming in. It's just coming in as web browsing. We don't know the specific app, but as we let the session continue, or we getting more packets coming in, we can then identify, oh, this is a Google Docs. Let's go ahead and allow it or block it. Now, if it isn't web browsing, generic web browsing, App ID cannot identify an application or label the traffic as generic web browsing. App ID can label it as either unknown TCP, unknown UDP, or unknown P2P. Okay. Now, going specifically into these four, web browsing and the unknowns, there's different ways to control it. There's three different methods. Either you block the unknowns in a security policy or rule. That's the easiest. Or allow it, whatever you choose. Usually you would block it. Another method is to create a custom application. Rather than block unknown traffic, first use network packet capture to identify unique bits and patterns of the application. So you do a little heuristics and behavior analysis, and you create a custom application signature to match that pattern. And then you name that custom application. And last, use the custom application in a security, quality of service, or BPF policy rule, like you use in PAN, predefined applications. Creating custom applications based on custom signatures is described in another course module. Let me dumb that down, summarize that. Pretty much you're looking at heuristics and metadata. You create a policy based off of those heuristic objects that you create. And then finally, another method for unknown traffic is application override policy. Suppose you need to manage a custom application. This is more specifically for a custom application within your based on security zone and IP address, destination zone and IP address, and port and protocol. Sometimes those custom applications aren't really known because they're homegrown, home developed. They're not something that's going to be proprietary. It's not going to be visible or public as app signatures in the Palo Alto database. So you have to create an override saying, hey, this specific application needs to be allowed because it's a custom application that we created. And the creation of these application override policies is described in another course as well. Now, control applications on SSL secure ports. Application default matches clear text applications on standard ports like port 80, SSL encrypted applications on secure ports like 443. Supported applications are web browsing, SFTP, FTP, LDAP, POP3, IMAP. So what you can do here is pretty much filter or allow or deny based off of secure ports or standard ports. that's pretty much what it's saying. The application default service, you can either allow secure ports to come in or allow both secure and standard, or just block standard. So malicious traffic often uses non-standard application ports. It's a way for them to obfuscate. Okay. So when you're reviewing firewall logs, one thing you want to do is make sure that the application itself is matching the service, it's matching the port that's coming in or out of. So if you're seeing that, SSH is coming through, or Telnet's coming through port 80 or port 53, there's something sus about that, right? Suspicious. That's not standard, right? So if there's non-standard port, if known services using non-standard ports that are not generically assigned to it, that's suspicious. That's a trigger warning. You have to do some investigation on it. And you can actually set up triggers and notifications and security policies to either block or allow. So in here, you see there's a bunch of rules here. You see that rule 1 blocks SSH traffic to tunnel traffic on any port. Okay. This one, rule 2, allows RDP traffic on only standard ports because service column application by default. So application default, it says you're only allowing RDP on the application default and allow it. So if RDP only comes through the default port for RDP. And then this rule 3 says MySQL traffic on only non-standard port 445 because the custom service MySQL 445 in the service column. So this specifically, this is more of the override policy I was saying. This is a custom application. We're saying allow MySQL only on this service of 45451, even though it's not custom. Sorry, even though it is non-standard, it's a custom service. Allow this to come through. Okay. Identify applications in decrypted traffic. So we talked a little bit about SSL decrypt. When traffic comes in, the firewall can do some SSL decrypt to be able to read the app itself and the signatures. Otherwise, it's a little hard to be able to. You have to set up security policies to understand how you want to go about and manage those encrypted traffic, because it can't really do much of the above what we talked about. Okay, so when you want to identify applications in encrypted SSL traffic, like I mentioned, App ID cannot use signatures and decoders to identify applications that's encrypted, because it's like all mixed and mumbled, right? It's not legible. However, the firewall does attempt to identify the encrypted application using 2 other methods. The first method relies on the common name field in a certificate, which typically contains the frequently qualified domain name of the server or its IP address. Okay. The second method relies on TLS protocol extension named server name indication, enabling multiple host names to be served over HTTPS over the same IP address. Okay. So the first one, a single website uses a unique IP address. The second one, multiple websites share the same IP address. Now, if a web server hosts only a single website, then the common name identifies the application. The SSL client initiates an SSL TLS connection to the web server and requests access to the website. The web server responds with a certificate that shows, hey, this is actually me. Remember, certificates show authenticity. And then the firewall uses a frequently or FQDN in the common name field to identify the application. In the example, the SSL client initiates a connection to Twitter. The web server certificate, which includes the common name, www.twitter.com, identifies the application as Twitter. The requirement that every website have a fully qualified domain name and IP address are not practical. So many web servers host multiple websites. The common name of a certificate cannot be used to identify the application because multiple web-based applications share a common, frequently qualified, or FQDN and IP address. Instead, the firewall can use SNI to attempt to identify the application itself. Okay? So, what does this all mean? If the web server is only serving one website, then the firewall can use the common name, the FQDN, and the IP address to label and identify that app. However, that's not always the case. Servers, some web servers host multiple websites, so you cannot use the FQDN and the IP address to be able to identify an application. And this is all if it's encrypted. So rather, the firewall can use the SNI, the server name indication, if multiple host names are served on that web server. So how does this work? During the TLS handshake, browser and applications use SNI to send the web server to the FQDN they want to connect to. The firewall reads the SNI field and attempts to use that fully qualified domain name in the SNI to identify the application. The web server reads the SNI field to determine which certificate to send it back to the client, verify the website's identity. In this example, the SSL client initiates a connection to app2.com. It includes app2 in the SNI field. The firewall uses the SNI information to identify the application. So pretty much what happens is in the TLS handshake, an SNI field is sent over to the firewall, and the firewall requests a certificate of the specific SNI that the web server is hosting. It's pretty much, it just adds a few extra steps. But relatively similar to if it was the server is just hosting one website. If it's hosting multiple websites, it's just a few extra steps. Now, migrating to an App ID-based security policy. Migrate Policy Optimizer. The Policy Optimizer provides a simple workflow to migrate your legacy or port-based security policy rules to an App ID rule-based rules. This improves security by reducing the attack surface and providing information about applications being used. So pretty much this is more of let's transfer old rules into, if you got a brand new firewall, you need to move over your old rules into new rules in this new firewall, this new device. The Policy Optimizer definitely helps you to do that. Enables you to clone existing firewall rules into ones that work with these next-gen firewalls or the PAN itself if it's a new PAN. Phase 1, identify legacy port-based policy rules, then add application-based rules above corresponding port-based rules, and then remove port-based rules. So what you do is when you're moving from old to new, from an old firewall to a new firewall, you have your old firewall rules, right? You want to identify those firewall rules. You want to implement them because they're port-based. You still want to implement them. And then you, on top of them, you want to add application-based rules above them. And then in phase 3, you remove anything underneath those, remove the port-based rules. Because they're just, this is more of a migration technique. The older rules are just redundant. Okay. And this is just like steps on, nothing specifically, this is just like best practices during the migration. And this is something that we can skip over. And this specifically shows, these next few slides shows how to do that cloning, and nothing specific that we need to go over here in this video. Is just steps of how to do it. Let's see, let's keep on scrolling. Add to this rule. result the math uses copies all, blah, 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 blah. Phase 3, while we're moving, now updating app ID. All right. Updating app ID and content ID depend on content type. So applications and threats, to maintain optimal protection, schedule regular content updates. If app ID cannot identify traffic, the content ID cannot inspect the traffic. So application identification and content inspection depend on applications and threats content updates. So what you have to do is to maintain a high level of protection, you need to schedule regular updates to your firewall. I mean, I think that's pretty understandable. You have to schedule regular downloads and installations of the new content updates. Make sure that you have a set time, right? It's free. It's a standard time of always updating. And if there's any ad hoc emergencies that you have to download, that you can do that relatively quickly after proper testing, obviously. If the app ID engine cannot identify the traffic using signatures, decoders, context, or heuristics, the traffic is labeled unknown and content inspection cannot be performed. Content ID cannot inspect the traffic because, like the app ID engine, it does not know or have the decoders and context necessary to read and interpret the traffic. App ID labels the 3 traffic types as unknown if they are malware internally developed in applications or commercially available applications. PAN has not yet added an application signature. All right. So in the next few slides, it just goes over how to schedule and download installs and updates every 30 minutes to ensure. Set the recurrence to every 30 minutes to ensure that your firewall sees new updates every 30 minutes. And I think these are just more of like how to do it, best practices. Let me just double check here. View policies, new application modify, yeah. So all in all, that kind of wraps up this lecture. We went over app ID, how to reduce attack surface, app ID concepts, policy rules, and the app ID application database. So with that, let me know if you have any questions, and I will see everyone next time. Thanks, everyone. Bye.